Well, let's look at representations of solutions. You know there's a large part of AP that looks at the different components and pictures and images that they give you, so I want to make sure we get a touch on those. Again, solutions are mixtures, right? They may be homogeneous, they may be heterogeneous, but they're mixtures. Sometimes they can denote this with color. I don't think they do that on the AP test because it's all black and white, but you can see that when we put them all together, A plus B plus C is going to have all those total partial pressures. Gases, liquids, and solids can be dissolved, so we always want to have representations being present. Again, you've got your water and carbon dioxide mixed together. You can see kind of random in a sense of that we have there. Again, you also have ions as solution. We've seen this a little bit before. And you might start to notice that around those you might have different orientations. This one doesn't seem to be too crystal clear on the orientation of the water molecules involved with this. But what you also might notice in this picture here, is that sodium chloride's a 1-to-1 ratio, and that you would have a 1-to-1 ratio across here. And also notice the distance between the two, that they wouldn't be close to each other. Another example, kind of again random, water and ethanol. A whole bunch of water, small amount of ethanol, again far apart. This is where they start to cluster together, that they have the hydrogen bonding clustering going on, but when you have a lot of it, they spread out to where the water molecules kind of break that from occurring. But this is, again, just another example of showing you that liquids can also be mixed together. Alloys, solids on solids. Alloys are all types of solutions. If it's completely soluble, you can see that in the solid solutions, all very much the same. This will also be called homogeneous. Partially soluble, see that some that kind of mix together a little bit here and there. And then insoluble would show very different delineation, thinking of like oil and water. Both types of alloys are still solutions though. So keep that in mind when we see different representations or you're having to draw your own. Show the correct amounts of each component, like I said with sodium chloride, or if you have strontium chloride would be 1-to-2 ratio, 1 strontium for every 2 chlorines. Direct the attractive forces in the correct direction. You wouldn't have things that are oppositely charged next to each other, and you want to have those water molecules pointing the right orientation with the positive hydrogens towards negative ions and the negatively charged oxygens towards the positive ions. Illustrate motion if possible between the states. So if you're kind of show from a solid to a liquid, showing that like it's increasing in motion when you have going from a, let's say, a solid to a liquid or a liquid to a gas. We'll have heterogeneous mixtures later to illustrate the differences states between those particle manners for solids, liquids, and gases. And label like the questions show. They always will give you something to go on and utilize that. So if they draw the structure, very simple structure, you draw the simple structure. If they say NH3 is a sphere, do it as a sphere. Always follow their guidance because that's what they're going to be looking at to make sense of your drawing. I think that's it. Yep. So come in with your questions and I'll see you soon. Take care. Bye-bye.